Hello everyone, welcome to Eminent Personality webinar. As you know, this is managed by Technologist. Technologist is based in Thailand. It's an international resource center for the industries and technologies. First of all, I'll just give you a quick intro to what is Eminent Personality webinar means. It's all about the professional journey of eminent persons who are well respected, well experienced, and also they contribute to the industry and also the growth of the fellow colleagues. That's all eminence, what we mean by eminence. Okay? We have few themes for the eminent program, and we have two types. One is the eminent rubber industry professionals, and in that one we have two sections. One is in conversation, the people are still here. The legacy is basically they are the people who are no more, but we would like to remember them. So we have a session focusing on the legacy of the eminent rubber person. And we also focus on the scientists as well. There is other segment, we focus on the scientists. That's the same format in conversation and the legacy. This is all about it. Why do we do this one? Because as you know, these experienced people have a lot to share with their experience, the lessons they learn. It will be very useful to the young people. I think we need to get to know them, what's happening, what they did in their 40, 50 years of journey. And so this eminent personality webinar is all about their journey, professional journey. Yeah. And we are here today for the in conversation with eminent rubber industry professional. I think you probably know, maybe some of you have joined our past programs. We have invited a number of people, there are many more, and each one is 40 to 65 plus years experience. And every story is interesting, every journey is interesting, a lot to learn, particularly young people, which is like a grandparents of the rubber industry, and their journey to be cherished. And we need to know what happened. So this in conversation with eminent rubber industry professionals is all about their journey. I'd like to convey my special thanks to Dr. Samar Bandyopadhyay. Actually, we are putting together, and without his help, I would not make it happen. And also, there are many other rubber industry friends, well-wishers, supported this program. I'm thankful to all of them. And also our publications, our network. As you know, I think many of you know this activity through the Rubber Technologist Global Network, and also our publication Rubber and Tire Digest. And a special thanks to Society for Industrial Chemistry, who have been actively supporting this program. I'm very much thankful to them. And I encourage all of you, if you're not a member of this society, please do so. And this society is basically a society for the scientists, chemists, chemical engineers. If you are any of this group working in the related chemical industry, I think I encourage you to join this society. Please do check more information at industrialchem.org. We have a co-host for this webinar. I'd like to thank our co-host, Holdwell Components, who believed in our cause. They want to be part of it. We are really happy to have them on board. They are basically a one-stop solution for all elastomeric needs. And special thanks to Mr. Kamalesh Jain. When I introduced about this one, yes, he'd like to be part of this program, Eminent Rubber Industry Professionals. And all these web recorded versions are today's one, it's available to view through our YouTube channel, Technologist channel. Please do check, even the past programs. You can view them at the Technologist channel. Okay. We are here today. Our invited guest is Mr. K.S. Loganathan, and he's a very, very famous person and a well-experienced person. We are going to have his story today, and he has more than 52 years of professional experience and 70 plus years old. And the agenda will be like this today. First, this is the remarks. After that, we have a short video presentation about the co-hosts and Technobase. After that, I invite Mr. K.S. Loganathan to share his experience, achievements, lessons to the audience. Then after that, we will have his colleagues, friends, basically share their association with him. By the way, I think you may have seen that there is a lucky draw in this program. We have 3 winners for this lucky draw, and basically the draw is the winners will get a book written by the Mr. K.S. Loganathan. After that, we have few questions. This is a format, so please make sure that you stay to the end. Okay, if you are there only, then you will get the book. Okay, so we already choose the winners, and we will announce it only at the end. Okay, as you see the program before the Q&A session. Please stay on. Yeah. Okay, let me introduce about the co-host, our Holdwell components. I will introduce their video. Please stand by. Okay. Thank you once again, Mr. Kamalesh Jain, for being part of this program. Let me quickly introduce about Technobiz. Technobiz, I think this is around close to 6 minutes presentation, is a video as well. You will know, you'll get to know what we are doing as a Technobiz. Please stay tuned. Just let me open it. Okay, thank you very much. I hope you find it useful, learn about what we are doing as a Technobase. If you need more information about Technobase, you know how to reach me. Okay, so thank you all for spending a time about the learn about the Technobase. So the man of the hour, this is Mr. K.S. Loganathan. As I mentioned to you, very well known, well experienced, very highly knowledgeable. Loganathan sir, please come on board, and we'd like to know about your story from your own, in your own words, please. Thank you very much. It's a very honor for us to be, to be with you today.
Thank you very much, Param. In this talk, I would like to share with the audience about 10 or 12 projects that I had been engaged in over the last 5 decades. And some of it is unfinished work, and some of it has a potential to be useful in the future. So I have titled this talk as Life in the Fast Lane, which is basically, in the last 50 years, I have been a spectator to all the developments in the automobile and the general rubber goods industries, and participated in certain situations where definite changes took place in the technology and in the applications over the period of time, and new products got introduced. So basically, in the past 50 years, the mobility of people has become very much accelerated. If you look at it in 1969, the world had about 3.9 billion people. Today it's 8 billion people. They were going at an average speed of 80 kilometers per hour. Today, you can go up to 315 kilometers per hour on a motorway in ultra high performance vehicles. This is almost the same speed as is there in Formula One racing and the landing of aircraft tires on the ground. So you can see that there has been a very great difference in the application as well as in the aspirations of the people. And what I call aspirational products have become a very significant part of a company's revenue. The person who was owning a cycle 50 years ago wanted to go to motorcycle, and then to cars, from small cars like Maruti to on to bigger vehicles, salons, so on and so forth, and right up to Lamborghinis and Mercedes S-Class vehicles. So this has happened because a large number of people who are aspirational and are moving up in the social scale have acquired a taste for trying out new and more value-added products. So the rubber industry is no exception, and we have had a lot of developments in the last 50 years, even in sectors which you would consider as a bit of backyard or retarded sectors. So this is a factor which we have to keep in mind. Next slide, please. Now, in the rubber industry, practical inventions have come before people had any understanding of the science, because the understanding of the science was basically at a macro level. That means you physically see a crack, you physically see a tire burst, or you physically find a product unserviceable because it has fallen to bits and it can no longer be used. The science behind it is based on a lot of trial and error. And even though molecular explanations of rubber behavior were there even in the 70s, particularly crystallization, kinetic theory of rubber elasticity, and certain phenomenological models, and so on. The behavior at the mesoscopic and microscopic level, that means, at the level of nano particles or even somewhat micro level particles, was very, very uh, primitive, so to say. It's partly because the instrumentation was not developed which could explore all these things, and therefore you had to make a lot of trial and error before you could get to a workable product and develop it. But as I said, the products were not very well advanced in the sense that it was pretty basic. There is not much failure that can happen if a product is having a quasi-static or a very slow speed running and does not develop heat, and it doesn't fall apart. So, for example, in bicycle tires or in motorcycle tires, moped, and so on, the speed was not a criteria. But as the products develop uh, higher speeds and higher load and more severe usage conditions, they have to perform better with essentially the same sort of materials that are available. Next slide, please. So in the past, the tackling factory problems and performance problems in the field depended on one's experience. The uh, person who was able to get a good dispersion just by looking at the compound coming out of the Banbury, or fabric who could find out that it is evenly coated and having no defects at all, could fairly ensure that defects in manufacturing were not passed on to the final product and become field failures, because the testing was basically derived from metallurgy, or the testing of physical testing of metals and monolithic materials, which were using single point low frequency conditions. But as you know, rubber is not a monolithic material. It starts off life as a unidimensional molecule, which is cross-linked strategically to produce a controlled network. And because of the nature of the polymer, uh, it's being mostly amorphous, the uh, the product depends very much on the time element. As it is viscoelastic in behavior, time is also a factor in the testing and in the usage of the rubber products. It is not necessarily a relevant factor in metals and metallurgy. So rubber testing also used to be based on physical conditions, single point low frequency testing, which did not cover the full spectrum of rubber behavior. That is the time, temperature superposition, and the fact that at very high frequencies, the problems occur both in processing and in performance. If you are going to stick to the linear part of the stress strain curve, as is the case with most metals, there is nothing much that can go wrong. But the moment you go into the case where hyperelasticity and the rubber-like behavior takes precedence over the simple Hookean elasticity, then it is very much time dependent and also dependent on the frequency at which the test is carried out, particularly in the case of dynamic products. Now, if you look at a tire, for example, it is part of a vehicle system and is expected to carry load at higher speeds. The vehicle itself is constituted of a lot of different types of materials and machinery strung together so that it is a multi-body dynamics, what is called as MBD, multi-body dynamics that is actually in play as far as the vehicle is concerned. If a load is applied on the vehicle because the passengers are sitting on it or because it's carrying a load, and friction is encountered when it is rolling, and when it is going uphill also there are forces which are acting on the vehicle to drag it down depending on the slope and so on, and friction between the tire and the road. When all these things are coming into play, the multi-body dynamics is applicable to all of the components which are used in the vehicle. For example, if the frequency is say about 0 or 5 hertz, the these conditions are considered as a quasi-static or almost static. I mean, it is just like a doormat or a flap which is there in the vehicle and is not necessarily taking much of a cyclic strain. But as you increase the vibration and as you increase the speed of the vehicle, the whole range goes from static conditions to involving a lot of phenomena like vehicle vibration, vehicle noise at the audio frequency level, and so on, including vehicle crash and various other phenomena which are being investigated now. There is no problem if you are going to run at about 30 kilometers per hour and over a very benign surface, road surface. But if you want to take it up to say 100 or 130 kilometers per hour, then the conventional cross-ply tire, which is used from the time of the invention of the pneumatic tire, is no longer able to take those frequencies, and it starts behaving in a very unbalanced way. Therefore, a lot of work was done to develop the radial tires so that the belt becomes a rigid component and is in contact with the road most of the time, and is mostly subjected to tension and not cycles of tension and compression which happens when the bias tire is used. In the bias tire, for example, the angle of the plies determines everything. In the basic bicycle, you have a cross ply of two plies at plus minus 45 degrees. That is, one is at 45 degrees in one direction, the other is at 45 degrees in the opposite bias to form a very simple slow moving vehicle. But as you increase the speed, these angles have to come down to something like 28 or 30 degrees for in the case of tires which have to go at 100 or 110 kilometers per hour. As you increase the speed, the problems start multiplying, and the construction is no longer a very robust construction. It starts falling apart because of standing waves which are created due to these frequencies at the ground tire contact level not being transmitted throughout the vehicle or throughout the tire even. So you have a runaway situation where the bias tire will not perform. The radial construction, by virtue of a very rigid belt is more stable, having a larger contact patch, and because of its flexibility in the sidewall, is able to roll along at fairly high speeds. So the radial tire, initial radial tire for the basic vehicles, car tires will be at about 180 kilometers per hour, if that is possible, which is S-rated tires. This was at the early stages of radial tire development, and the aspect ratio, that means the almost balloon type of tire which was there in the cross ply became squatter and squatter, so that from the aspect ratio of almost 98 in 1920s, the aspect ratio started falling to 70 in the 1970s when I started my journey, and today has reached almost 25. That means the tire has is not a cylinder, but it has become more like a barrel which is rolling around at very high speeds, and therefore it is totally different material altogether. In the bias ply tire, as I said, the angle determines everything. But in the radial ply tires, it is possible to have at least 3 different type of angles without detriment to the structural integrity of the tire. So when you have 3 different angles and you can dispose it in many directions, the scope for maneuvering the design to respond to 3-dimensional stresses and strains becomes all the more greater. So you can turn at high speed, you can take a U-turn at high speed, you can turn right or left at very high speeds and so on without losing the stability of the vehicle and so on. If you recall, in the beginning of 2000, 2001, there were a number of crashes which were reported in the Bombay-Pune highway, and that was biased car tires fitted. And because the motorway was just coming into prominence in India, the owners were very happy to run it at a full speed of the car. Even though the mileometer goes up to 180 kilometers per hour or 200 kilometers per hour in some of the basic vehicles like Maruti 800, Maruti 1000 and so on, all the components are not homologated or passed for that type of operation, because as I said, the tire is only suited for maybe 113 kilometer per hour. So you go at 150 kilometer per hour, the tire burst is bound to happen. And when the vehicle or the tire becomes unsteady, it overturns and causing a fatal crash. So radial tires did give relief to this problem because they could be run at higher speed. But even today, the awareness among the public about this problem is not so much as we would like. For example, recently, there have been a lot of crashes on the Yamuna Expressway involving Maruti Wagon-R type of vehicles. I do not know what type of tires were fitted in them, but there were quite a few fatalities because we are using old vehicles on new roadways with parts not exactly suited for these type of running conditions. That is one of the reasons why I put the title is Life is on the Fast Lane, because it's nice to go hurtling at high speeds, but if you must be on the right vehicle. So at the factory level, if you use single point low frequency conditions as we had access to in only in the 70s, you could not do much to correlate processing behavior with your compound formulation and so on. The first project which I was given when I joined Dunlop in 1969 was a very interesting one, wherein the problems of vulcanization have to be studied with a cure meter. The grandfather of all the rheometers, that is the Agfa vulcameter, had just arrived from Germany, and when people could not make head or tail of it, I was given the task to start and get it going. The problem was all the manuals were in German, and I took the help of Mr. Sashidhar Rao, a good friend of mine who was pursuing studies in IIT Madras, to get my whole manuscript translated, and then I started working on it. You see, this is a compression type of rheometer, which is a parallel plate. You have to insert 2 specimens, and it is in the open air, and it was giving fairly slightly larger amplitude of oscillation. And as the vulcanization progressed, you could get a double curve on about 3 out of the 5 samples which you test. The 2 samples used to be spoiled because you cannot put the exact amount in the right thickness in the right time and hold the temperature for 45 minutes. But the tests were replicative of the processing conditions at that time because the temperature was taken around 140, 150, 160 degrees. And traces used to come out beautifully. I could take the reaction rates and plot it on a semi-log scale and find out the reaction rate for various types of compounding systems, and the company was producing some 32 different type of product groups from the bicycle tire to the aircraft tire to conveyor belt and so on. So there are some 200 compounds galore, and all these things we could make some sort of study. I soon ran into a problem where I found that the usage of the materials is not matching the model of vulcanization which I had in mind. That means, if you are going to have a sulfur cross-link, you put a certain amount of sulfur, say 3 parts in 100 parts of rubber, and you take the rheometric trace. You change the compound formulation by using a different filler or accelerator or even sometimes, antioxidants, and the cure chemistry changes and something or the other is out of balance. Nobody can say which. My boss SB Ganguly sweetly explained to me that there are overages added in the rubber compound because of reactions which continue in the tire molding, after the tire molding, and in the tire usage in the field, and so on, and even in storage and so on. The problem is that it is not a satisfactory answer for a chemist in the sense that non-stoichiometric proportions are used to bring out a vulcanization reaction. And you have excess of zinc oxide, you have deficiency of something else, you have excess of sulfur, and so on. And you are assembling a composite with, say, nylon or steel or any other material with different type of adhesives, and the whole thing becomes a merry pudding, because some of the reactions which you want to continue, like say the migration of antioxidants, anti-degradations to the surface and preventing the cracking of the tread surface, are beneficial, but others attack the core of the tire and cause separations. For example, in the bead failure due to interaction of rubber and the component in the coating of the steel cord in the bead wire, which led to some disastrous situation in Firestone 500 in the 1970s, and so on. Even today, the problem is not solved, because if you are not able to add the right amounts, it becomes a matter of trial and error. According to me, compounding is a perpetual matter of trial and error. You just try to put it in the statistical quality control chart and hope that everything passes and it doesn't fail. But it cannot be given a particular shelf life, say 5 or 6 or 7 years guaranteed shelf life, or purely on the basis of the compounding, because a lot of factors come into play during the vulcanization, during the storage in the tires, during the storage conditions, and so on. And therefore, it's a work in progress. You do something, you make the tire, you put it on the field, and you hope that things don't go haywire. Things did go haywire, for example, in rayon, where the common misconception was that once you fit a tire onto a rim and inflate it, it is waterproof. It is a barrier, because even a thin coating of rubber on Macintosh on your rainwear is good enough to keep the raindrops away. So if any splash on the road can be easily withstood by the rubber, and it never attacks a rayon. It is actually a misconception, because if you store the tire off the rim, the moisture seeps in and enters the rayon, and the most problem with the organic fibers is they are all hydrophilic, whereas rubber is hydrophobic. So there is something which is attracting the moisture and which is wicking it throughout the tire, and there are other things which are repelling it, definitely leading to a situation where ply looseness and separations can occur. So the problem is still a work in progress. If you want to study moisture ingress into the tire, radial tires particularly, don't tell me that if you have a radial tire inflated and running, with steel cord or with any polyester steel combination, that moisture is not going to enter it. It is only a pious hope, and not much study has been done on this aspect, at least not that I see in print. Some companies may keep it to themselves, and that may be the situation now. Next slide, please. Next one. So here I was coming to the going at breakneck speeds, like 315 kilometers per hour. See, ultimately, rubbery behavior results from the amorphous portions of the rubber molecule, which are uh, constituting the compound. If rubber were not essential, then you would use something else. But because there's no substitute for rubber, even though it is weak, the molecular motions in the rubbery phase are of paramount importance. These molecular motions are dependent on frequency, dependent on time, dependent on temperature, and as part of the multi-body system, it stands to reason that there is a limit to what you can take the rubber. Now, if somebody says tomorrow we want to go at 500 kilometers per hour and take off and then land at 320 kilometers per hour and so on and so forth, I don't think the molecular motions in the rubber are going to be able to take it, because they are only capable of limited type of motions. That means there is a sliding motion, there is a rotating motion, there is a translation motion. And when it starts sliding and translating, it is going to become liquid, and when it liquefies, it's going to be not able to bear any load. There's only to a certain extent that you can reinforce it, and you can bond it with a stronger product like a fiber. Please bear in mind that when you bond rubber and fiber, the two are totally different in character. One is more amorphous in nature. The fiber is, as a rule, highly crystalline and oriented in a longitudinal direction, because it has to impart strength. Much like concrete is reinforced by twisted cord. Next slide, please. So in those days, this type of analysis was not possible, and the only recourse was to go on testing on the pulley wheel or machine testing, followed by road testing and limited field trials. For example, one of the rayon tires which was introduced in the 1970s had done 8 crore kilometer of such testing on the road. There used to be a fleet of 4 trucks running from Saganj factory to Bardwan and back every day, with the same load, with the same type of tires in control, against the standard, and for months together, and before you can check that the tire is not cracking or it is not growing beyond the limit specified, and so on. The type of processing testers and the facility to change the pulley wheel conditions and all did not exist. It was just a single point measurement, go, no go, that's all. So we have to depend more on the failure statistics from the field. So if you sold 1,000 tires and 10 came back, you have to take it back, test and see what has happened, gone wrong with it, check the residual property, because there is nobody can give you the strength of the rubber or the strength of the textile or the steel cord in the new state or in the final state. The so-called strength was very heavily dependent on the flaws in the or the absence of flaws on the polymer. So residual property determination is more important than the strength if you are going to depend on the field testing. The second point which you have to note is that if you are going to depend on field testing of thousands of tires and analyze the failure statistics, you got to be the master or the PhD in statistics, or you got to be the data science wizard. Next slide, please. Now, in the 1970s, it was a very interesting time because there were three rayon tire cord manufacturers, and they were gradually replaced by three nylon tire cord manufacturers. In India, it was nylon 6, so these plants began operations. In shifting over from rayon to nylon, it was necessary to upgrade the heat stretching machines to be able to handle much higher tensions and loads than was possible with rayon. In shifting from cotton to rayon in the 70s, there was not much of a problem because cotton and rayon could be processed on the same type of machinery with almost similar dip, except the addition of a polar material like vinyl pyridine latex, and the tensions were not very great. Both are cellulosic fibers. But when nylon 6 or nylon 6s came into the picture, and later on polyester, the tensions developed during heat stretching was very high, and therefore required very much robust machines to start stretching and stabilizing the cord. Just as is mentioned, the case of temperature and time effects on rubber, in the nylon polymer also, the shrinkage and the behavior under higher temperatures was anomalous, in the sense that you could end up with distorted products if you did not heat stretch it properly. And therefore, heat stretching and dipping of nylon became a very important part of the operations. Please remember that during this time, cotton was also very much in use. There were 6,000 metric tons of cotton used every year in the early 70s, some of it even going into car tires and tractor tires and agricultural tires. Therefore, the reliance on the cotton companies, cotton fabricating manufacturers and processors and converters was very high. Dunlop had a very good partnership with Madura Coats, even though the companies were not owned jointly or there was no cross-holding or shareholding at that time, because of the nature of the business. Today you find that people want to introduce biocomposites. You want to introduce, say, cotton. We have used cotton in practically every type of tires. Okay, it was not running at 300 or 200 kilometers per hour, but it was doing a fair job at 50, 60 kilometers per hour in most of the operations. And in that type of situation, the cotton depended very much on the crop and on the converter. So twice a year there used to be meetings. That is, one when the budget was announced, because the duties on cotton vis-a-vis man-made fiber was a very big question. Dunlop and Madura Coats were trying to see how best to handle the duty structure, which would overnight it will change. You see, in India, by starting on the road of industrialization before some other countries, actually complicated the situation, because if you don't have any industry, you can have all products charged at, say, 8% duty. So the government gets 8%. If you have all products at 100% industrialization, everybody is in a free competition and it is a fair market, also you can have 8%, as it was the case in Japan. They're producing every product, doesn't matter, if you're making rayon or nylon or cotton or whatever it is. But here a swing from one to the other will drive many people out of business and will drive many workers out of work. There are 20,000 people engaged in Madura Coats in those days before it folded. As I said, 6,000 tons, and Gokak mills and Simplex mills and so on. There's a roaring cotton textile business in Maharashtra and in Karnataka, which was going into industrial product uses like conveyor belting, transmission belting, and hoses and so on. Now, within its limits, cotton is an excellent fiber and can be used very well. And as an advantage, that you are only a niche player in the big cotton market. If you recall, cotton was a gambling commodity. People used to bet on the New York Cotton Exchange. You can't. I don't see any nylon betting or rayon betting which took place at that time, because it's supposed to be a controlled commodity specification, etc., etc. Similar approaches was happening in natural rubber also at that time. The sheet rubber became from an estate crop, it became a smallholders crop, and from a smallholders crop, people, especially in Western consumers in Europe and USA, they wanted a technically specified product. So a technically specified product means you test it to specification, which was laid down by the tire companies or by the rubber boards of the countries, and you give a certificate with each lot as is demanded for statistical quality control. Next slide, please. Now, in the case of textiles, I was at having an advantage that there was nobody in the company who had an idea, a clue about all this industrial textiles. There was no textile technologist actually, because the textile technologists were in those days, and even now I believe it's the case, were only knowing how to treat cotton, wool, and silk, nothing else. Man-made fibers, zero. So the company talked to all its major suppliers and also engaged some external consultants who are UNIDO training consultants to train me in all aspects of industrial textiles in cooperation with various industry research organizations like Shirley Institute and so on. And so this one man was trained in all the aspects and put on the job, as they say, you are the textile expert from 1973. Now go ahead and prove this Zell heat setting and dipping machine. It is my experience in life that there is a group which orders the machinery. There is another group which is executing the project installation. And after everything is done and the ribbon is cut, there are two groups which are brought into the picture who have not seen the thing until that day. They are supposed to run it firstly and produce a satisfactory product, and secondly to bump productivity up to the highest possible levels which are claimed by the manufacturer who supplied the machinery. This was the case here also, and so in the process you learned a lot about how to tackle nylon and the various problems of nylon vis-a-vis rayon, which was at that time the major fiber. And the problem was that even with the little knowledge which I had at that time, I could see that even the people who are producing nylon 6 fabrics, tire cord, etc., in those days had no clue about what it was going on. Sad to say that today also the situation is almost the same, in the sense that you don't have a Dunlop Madura industrial textile coats type of partnership, in the mutual interest to develop the product, without having non-disclosure agreement, patent agreement, this, that, and all. Even before baby is born, all the paraphernalia, including divorce and annulment and all, have to be decided. So that type of relationship, if it does not exist then and if it does not exist today, I think it is going to be very difficult to develop green composites, because it is not that we have to bring back knowledge of cotton and all, which hardly anybody now would be very well aware of the aspects of industrial textiles using cotton. The producers also have to produce the quality which is consistent with very variable raw material and so on, and meet the productivity norms which are there. It is much like what Mahatma Gandhi faced, mill-made cloth coming from Lancashire, taking away the livelihoods, and then you have to go back to the Takli. Next slide, please. So here is the what I was talking about, molecular motions, and the problem in coupling fibers and for reinforcing rubber products is basically that unlike monolithic materials like steel or metals or stone for that matter, you are now ending with a composite. Actually, it is a composite within a composite because a rubber compound is also containing nanoparticles like carbon and silica, and then you that is reinforcing the rubber, and then you are reinforcing the rubber compound with the textile and co-vulcanizing it. So if you see this graph, you have got linear rubber and textile molecules which are cross-linked by sulfur bridges during the process of vulcanization, and also there is entanglement because the adhesive in the form of RFL dip is applied in the liquid state. Both organic fibers and rubber are low surface energy materials in the sense that they will not stick. So you need an adhesive, and you need a rubbery adhesive at that to reconcile the difference in modulus or stiffness between the two. And as you know, the composites generally depend on the matching of strength, stiffness, and toughness of the partner materials. Say if you use two or binary or many other materials, etc., they all have to be matched in to give you the graded level of strength, stiffness, and hardness. No, I mean toughness. In the process, if it is mismatched, you get distortions. Like I have shown that you assume that tire cord, when you lay one on top of the other, it will be flat. No, but it will curl, it will twist, it will turn. Not only in vulcanization, if you get it right in vulcanization, you will find that in running, it has got twisted and it starts separating and so on and so forth. So dynamically, to get this composite moving itself is a task because first of all, you are using single frequency tests on the rubber, and then you are having pull-out test on the fabric only to see whether it is met the desired adhesive properties. And when you are cross-linked it, you have no idea that how the whole thing is to perform, except to see it collapse. So this problem also remains to this day. And introducing steel introduce a whole different type of adhesives in the sense that steel is a high surface energy material. Glass is also a high surface energy material, but rubber is a low surface energy material. To marry the two, you got to have something in between, which has got intermediate modulus, intermediate properties, intermediate strength, and intermediate properties of control thickness at micro level. Please understand you are not doing any micro level testing yet or nano level testing yet. Those instruments are developed only a few years ago, and I don't think many people in the rubber industry are acquainted with that. Next slide, please. Now, here I must point out one thing. People say that there is a shortage of tires. There is a shortage of raw material. There's shortage now of semiconductors. China is not able to have energy, etc. Shortage, But you look at the consumption graphs, steadily going up. Despite all the shocks of the 70s, the rubber industry was belting out a 10+% compounded annual growth rate throughout the period. Why? My submission is it is not depending on the manufacturers, or if it is not depending on the government or any other agency, it is because the people want it. So when you talk of material shortages and the profit motive of the companies and so on and so forth, please stop and think why they are producing it. This is because there is a public demand. There's a public demand because the people are aspirational. They want bigger things. They want faster things. They want more affluent lifestyles. Next slide, please. Now, when coming back to rubber, At the same time as all these exciting things were happening on the fiber, rayon to nylon, and then some polyester also started showing up in industrial products at that time, particularly V belts. There was a pressure to improve rubber, that is natural rubber, which was a major commodity at that time. So Dunlop had the foresight to start a rubber research laboratory in Cochin because the two factories were actually far away and they could not communicate properly with the people who are growing and supplying. The dealers were large network of dealers were supplying the rubber at that time, and orders had been placed in the rubber purchasing department at Cochin. So a laboratory was set up, and people thought at that time that it was going to be a competitor to the rubber board. But it so happened that the lab actually had only about 3 persons, including me, running the show. And the vital difference between the rubber board and the Dunlop Rubber Research Laboratory was that the rubber board is interested in the pain points of the producers, the prices, the commodity movements, the crop failures, the fertilizers and the pesticides to be used in the estates and so on and so forth, which is not going into the final tire. But the Dunlop as a major consumer at that time was more interested in the consumer pain points. So it so happened that in its 14-year life before it was wound up, the laboratory produced some very good stuff on non-rubber constituents of rubber, which had been not much looked at. See, if you study natural rubber, the natural rubber actually is supplied as a 93%, approximately 93% pure polyisoprene, cis-1,4 polyisoprene rubber. The balance being made of the proteins and the acetone extractables, fats and so on and so forth. So about 3 or 4% of fats and steroids and all these things, and 4% of nitrogen protein, which is basically relating to about 0.6, 0.7% nitrogen. Now, at that time, Rubber Research Institute of Sri Lanka had a very good band of researchers headed by at that time M. Natarajan, who is a doyen of the Sri Lankan rubber industry, particularly in the Tamil plantations, and a person with a longer name than mine, P.S.Sri Abhay Singhe Jayavardhane Yapa, P.A.J. Yapa. He and Mr. Natarajan formed a new process. The beauty of the process is you use field materials and not formic acid or any other acid to coagulate the latex, and you keep the nitrogen content down to below 0.15%. That means 5-fold decrease of nitrogen, which is making it a deproteinized rubber. By this process, you can make skim rubber into an ordinary rubber, that means acid coagulated rubber, and you can make it acid coagulated rubber to be deproteinized rubber. Now, there used to be a joke at that time in the estates that only 2 chemicals are needed by the rubber grower. One is formic acid, the other is Scotch whiskey. So, in that we are saying that we don't need anything at all. You just use the enzymes to coagulate the latex and you will get a much purer product and which can be used for good uses. So I was convinced at that time as a technologist to go along this way, and we did a very detailed study involving field testing in agricultural tire products of papain treatment of natural rubber latex, which will produce superior quality deproteinized rubber. This is the paper which I am still having. The difference is that this paper is based actually on entirely reporting all the results of field trials, both in the Rubber Research Institute of Sri Lanka laboratories in Darton Field, and also field results of Dunlop, which were out of the product. So it was quite a detailed one. Even the latest patents that you make nowadays will not have this level of detail. This was the extent of the social commitment which was there. And I'll read part of the report. The method of papain treatment is fairly simple and can be directly applied to fresh EVA latex. It can also be used on skim latex to produce low protein rubber, etc., etc. And it goes on to say the main drawback as regards commercial implementation of papain treatment is the low availability and consequent high price of papain in NR producing countries. This can be overcome by rubber plantations producing their own papain by growing papaya tree as an intercrop in the immature rubber plantations. I'm sorry to say that even today deproteinized rubber is looked upon as something like avoiding latex allergy or improving the electrical properties. But I have at that time arranged for import of a container load of rubber produced at Darton Field, which we have tested in the factory. Because of deteriorating relations between India and Sri Lanka at those times, particularly with the Tamils and Sri Lankans in those times, it took 2 years to import it and get it into the country. And after 2 years after production also, I could test it and see it was as pristine as a neat deproteinized rubber produced in Darton Field. There is no complication of properties going haywire because of plasticity, not maintained retention, rubber hardening, storage hardening, etc., etc., all that thing. But somehow or other we have lost the thread of this development. And even now you find 1 or 2 patents coming from China on this subject. But the major advantage which I found was that rubber does not crack. Deproteinized rubber, it will not become mold ridden or fungus ridden, etc. It will keep for a much longer period. So I am convinced that natural rubber is being spoiled by the proteins. Proteins may be good in various ways and sometimes as a health supplement, but not for natural rubber. That is the conclusion I came to. Next slide, please. So another thing was the statistical rubber scheme was introduced. We had can you believe it or not, 1,000-ton rejection of natural rubber because it was very poorly graded and sorted. And so we went through almost 300 dealers, go downs, etc., with the help of the Indian Statistical Institute, and developed a scheme for grading sheet rubber, which was in operation under my supervision from 1979 to 1992. Not a single problem of the type which we have encountered in the late 70s was thereafter encountered. I vouch this thing. Unfortunately, it has not become a standard in any organization because, they do not want to go into it. You have technically specified rubber, you buy technically specified rubber. Why do you want to grade it? Or if you want to grade it, why do you want to check for non-conformities in the graded rubber? But I have discussed with a lot of people, the problem in the farm sector is the variability, but you will not be able to do statistical analysis of a very variable agricultural product in a detailed fashion and still have it hold water for 14 years. I am prepared to offer it to whoever is interested. Please take it and try it if you are interested in that sort of a scheme. It was a brilliant work by Indian Statistical Institute, Calcutta, and we had the sense to keep it going for as long as we did. Next slide, please. In the mid 80s, suddenly a lot of developments happened in the mid 80s. Srinivasan also mentioned that he was drawing a big plan at that time for modernization of Dunlop. And so steel cord belting, power transmission belt, hose, etc., all came with international collaboration. And but somehow the passenger radial tires didn't take off because the road infrastructure was pretty bad. So that product lagged behind the rest of the world by almost 20-25 years. Whereas steel cord, you won't believe it, steel cord belting came in, like a flash in the mid 80s, and it was adopted by the mines. You cannot believe that all these coal mafia and the people in the mining industries, worldwide, they are shown as tormenting people and so on and so forth. These new technologies are adopted like anything. Why? Because the people wanted. The people wanted the goods moved. Somehow or other, you have to get the coal to the market, you have to get the iron ore to the market, you have to export it to Japan and other countries and so on and so forth. Because the demand is there, the manufacturers also go in and produce superior products. And I will show you that steel belt, for example, has much higher carrying capacity than the nylon or polyester nylon belting, which was a competitor in those days. And the strength rating is 5 times greater as compared to textile belting. Next slide, please. Now, today, passenger car tire sidewall looks like this. Now, there's no point magnifying it because there are enough letters and alphabets to fill up the whole tire. This is in response to consumer demands that you must mention the speed, you must mention the load, factory where it was made, you must grade the tire according to various specifications, including rolling resistance, this, that, whatnot, whether it is for tubeless or tubed, and whether it is having some other features like mud and snow and rain and so forth, reinforced and so on. Now, can anybody who's a layman make sense out of this? This can be only decoded by either a tire expert, or it can be decoded by somebody who's a claim settler, either in the government or in the purchaser among the major tire companies. I mean major tire producers, purchasers, etc. Whereas the common man is hurtling along at Yamuna Expressway at breakneck speeds and is having privy to this information, but the information, I think, is a bit overdone. Next slide, please. This I was explaining that the market suddenly shifted from cotton to polyester, nylon polyester within a matter of 10 years, and then to steel. And the strength rating had kind of gone up from, say, 315 to 10,000. Can you imagine this sort of development happening in the mining sector? Next slide, please. Now, another caution I must draw on the truck tire situation. At that time, single axle trucks was there, not only in India, but in many parts of Southeast Asia, and overloading was rampant. The reason again being that you have to move 3 or 4 times the goods and with the same resources, and the trucks are overloaded to 3 times this design specification. Sad to say, some companies took that as a challenge and produced oversized tires which are higher size than the international standard with extra reinforcement, which got a fairly good reception in India and the overseas markets where overloading was rampant, like Latin America and some parts of Taiwan and Vietnam and so on. In my technical opinion, this is not a sound policy to encourage people to misuse their product, which has been designed for a particular purpose of use. And claiming technical superiority in the out of the range parameters is also not a good marketing practice or ethical practice. Next slide, please. Now, at this time, because of the welter of new products coming in, the companies which could not add value and come fast to market and could not curb their energy and labor costs, they grew weaker in the marketplace. New companies came in. As you know, 3 or 4 Indian tire companies came into existence in the late 70s, mid 80s, and they gradually got into the market share of the larger companies which were at that time there for a number of years. Next slide, please. Now, as I said, failure statistics are an important part of a technical manager's life, and you have to analyze it and find out the probability, causes, correlation, causation, etc. All whatever the data scientist is doing today, we had to do 50 years back with a lot less computing power. Today, it might have taken 2 or 3 days to do the same type of statistical analysis. That time it took many people several months to get it together. Next slide, please. One of the reports which I am particularly happy about my projects is that the very first project in tires, which was given to me in 1970, involved this. This is only executive summary. There is a 300-page attachment to this, which has gone with the wind. Correlation of process changes with service failures for commercial truck tires for both Dunlop and Shah number 2 factories. I was given a task of coordinating with various departments, collecting the data as a fresh IIT graduate to develop a forecasting method and to see that process changes, how process changes are influencing the service return variability. Now, I'm only putting it, this may not be of much relevance to today's tire manufacturers, but the technique is very much relevant. We are talking of 2 rayon tires in those days. And I could develop a forecasting method and predicted various things, starting with 1,100 variables which could have caused problems. It was gradually whittled down to about 36 and then to 11 important variables which could be quantified and put into model equations. That is algorithms in today's parlance. We would call them equations in those days. So you have the data science project in the sense that you have to collect the data, you have to clean the data, you have to sort out the data, you have to try out various cross-impact matrices, and then you have to come to a conclusion. Okay, I've come to the conclusion. What is the conclusion? 80% of the variability in the field return statistics is due to design changes. Then further analysis was done and we found another 15% came as a result of marketing warranty shifts. You know, they have the time to time, they change the warranty scheme and then something happens, something goes up and something goes down, etc., etc. And the reaction of the management is going to be the same today, even if I have to work and as a 25-year-old and produce the same report with a different management, I'm sure it will be like this. Next slide, please. This, no, please stay on slide 18. The report evokes shock and awe laced with mathematical and algorithm aversion. This is called mathematical and algorithm aversion. You don't like anything with equations on it. And you don't like any models which has been done by calculation has been done by machine. I will trust my judgment. No, this fellow is talking nonsense. So that is much the attitude. So where is your data science going to take you if you are going to do like this? And even for today's problem is the algorithm itself is biased because, you know, if you take a picture of 100 people in the world in the algorithms which, you know, Google and other companies trot out, 90% of them will be white, 1% will be brown and 1% will be yellow in color. So facial recognition of this type will put all Indians or Chinese as criminals. So naturally there will be algorithm aversion. So when you have introduced the bias, it's going to be algorithm or not, it is not going to be believed. Next slide, please. Now, nevertheless, we statisticians have to prod along, and here I've used the Fisher-Price technique to predict Indian tire radialization trends, which is say almost completed in car tires, 90% in light truck by 2027, and truck is in 2036, notwithstanding COVID and some temporary blips on the way. Actually, a 25 to 30-year lag from the world trends. It's very easy to forecast anything sitting in India. You just have to find out what those fellows did 25 years ago. I mean, this is the state of affairs. Next. So this is just the calculation of how it is lagging behind the world trends. Next slide, please. So now that is most of the projects which were in sort of work in process, not completed, did not give me happiness, still scope where somebody else can start and do the things which I did not complete, and so on. But look at what is happening everywhere in the world. You know, it's not only rubber, it's industry 4.0, 5G has come in, and robots have come in a big way, cobots have come in a big way. How, as a developing world with a very young population and where jobs are not going to be easily available, and even the jobs which are there are going to disappear, is going to cope with this changing scenario in the coming decade? I mean, it's not a scenario that somebody foresaw like Nostradamus 4 centuries ago when he didn't know the technology. This is the future that has already come. It is foreshadowed. Next slide, please. Now, we are dealing essentially with a composite product for which at the moment there is no ready substitute. And we want all a circular economy. For your information, the rubber circular economy is only 8% compared to say 40-50% of metals, glass, etc., and other industrial products, industrial structural materials, and so on, and nowhere near 100%. So you have to depend on reuse and reduction, and reduce the energy usage through different means if you are to meet the global warming targets and SDG 2030, which is agreed by all the countries. Next slide, please. So here I have 3 different points of view. Actually, only 2 are in the public domain so far. Greta Thunberg, the Swedish environmental activist, she says we are still speeding in the wrong direction. She's going hammer and tongs at the world governments for being slow on implementing all these things. 75 years back, Mahatma Gandhi has said, the world has enough for everyone's needs, but not everyone's greed. So he wanted people to weave their own cloth, to live in Sabarmati ashram, to not to crave after good things, and so on and so forth. Now, I will leave with your problem. Now, who has created the demand? And who has created the market pull? And who are the regulators? I think there is a confusion in this situation because there is a lot of interlinks. You cannot expect the individuals to do sustainable things throughout whatever they are producing. In my home, for example, everything that is in the bazaar is available, 1 or 2 pieces of each, because that's how we want it. We want 2 hair dryers, you want 2. You don't know because when the power will go, this and that. So everything which is in the bazaar is there in my house, and because it's in my house, the bazaar also is selling. Next slide, please. I think the problem is when these roles are confused, it is not very proper to put the blame on the government or on the people or on the corporate level, so on, the companies and so on. Next slide. So in this decade, I'm assuming the technology is available very much in molecular dynamic simulation. That means at the meso and macro level, you can tear down any molecule or adhesive structure, and you can arrive at a very good understanding of how the assembly is twisting, turning, and so on. Stiffness is getting lost, or strength is getting lost, and so on and so forth. and also additive manufacturing of processing, though the properties now are much lower than what we would get out of conventional assembly. This is also bound to improve in this decade. Next slide, please. Next slide. Okay. Now, we mentioned already about biocomposites and green processes, but it depends on a lot of collaboration. I don't see it happening with the government. Say they're talking of technical textiles, you will put a big package, but nobody's saying for bringing back cotton into industrial usage or jute into industrial usage or anything like that, that we will put a big project and one or two of the IITs will get engaged in it, and the industry will share the findings and produce products which are more sustainable and so on, and bump up that 8% to something better. I don't see that happening. Next slide, please. Now, nanotechnology has been around from the 1990s, and you would have seen a lot of things in the rubber industry also. Polymer property enhancement at the molecular level. Most of the thrust is going into medicine, pharmaceutical, and health because they have the profitability to keep it going. In the rubber industry, it has been rather slow in coming, but the technology is getting advanced all the same. We can claim that we are already using nanotechnology in the shape of carbon black and silica, which are actually nanofillers but aggregated because of Brownian motion during the manufacture. They are aggregated, agglomerated, and so on. So we will have to deal with nanotechnology in the coming years. Next, please. So now I bring COVID-19 into the picture. Last year and this year, people are working from home. Now I see that industries and offices are getting restarted. I am actually broadcasting from a co-live facility which did not exist a year back. It is because of COVID and all that, where the home cannot be an office and the office cannot be a home. In between, you have something which is halfway street. So that way the things are going to change. But you also have to change when you prepare for a career in the next decade to 2 decades, etc. Next slide, please. So, as it is expected that I give some advice to young researchers or professionals, so I have given 4 items. The first one is to Lord Krishna. You be a karma yogi. The second one is due to Epictetus, who says, play the role expected of you. You cannot give your life for the community if you are going to neglect the family or your neighbors. So you have to play different roles, and that's going to take a portion of your time and your investments and energy. Third is to be in harmony with nature, not in competition with it. And the fourth is to keep learning and networking. Now, at this point, I must mention that the half-life of an engineering or science degree used to be 3 or 4 years earlier. You study for 4 years and you could use it for 4 years. But today it's rapidly diminishing, and the half-life is down to a question of months. So lifelong learning is going to be the thing, and the degrees are going to be less important than keeping on learning something in the coming decade and so on. Next slide, please. Now I come to my contributions in the public domain. Next slide, please. This is the rubber engineering, which was brought out in 1998. This year I have brought out this month actually. So I want to share with you. This is the book which has just been published, Reinforcing Fibers in Tires and Mechanical Rubber Goods. This is as big a tome as the other one which you may be familiar with, Rubber Engineering, except that it has been made like a coffee table size, 500 pages with A4 size, a lot of materials, charts, diagrams, etc. etc. Assuming that it is either a graduate or an early researcher or practitioner in the rubber industry. I commend it simply to gain knowledge. Next slide, please. Now, these are my publications. So I will just draw one comment on this. There are about, say, 2 books and some 3 reviews and about 18 papers, all of which are printed papers. Together, they make a grand sum of 1 million words in print. And apart from that, I have produced about 5 million papers, which are in the private correspondence and private domain, not yet in public, and because I have been a consultant most of the time. Now, the downside of it is, okay, this is a very learned man and he has produced some things which will be helpful, etc., etc. The upside. The downside is I have calculated that the amount of paper I have consumed and writing and reading, my copies alone, not selling it to you and taking that also into my shoulders, is equivalent to cutting 111 trees. This is only paper consumption in so far with me. I have managed to plant 58 trees in various situations I was in, for which land I had access and I could ownership and so on and so forth. But beyond that, I am not able to find land to plant trees. Now, if I have not calculated the carbon footprint I have taken by flying or by traveling by car or by using something fossil fuel or using something else at home and so on and so forth. Just simple reading is enough to devastate the entire forests of, say, North America. Now, this type of calculation is not placed in the public domain because it will scare the public. But I want you as young researchers and people entering the industry to think deeply. If you cannot do without it, if you have to do something, and how best to leave as little a carbon footprint as possible on an individual level. That way, you're moving to closer to the Mahatma Gandhi exhortation that, don't do this, don't do that, and avoid greed and so on and so forth. But you have to tailor your lifestyle and your carbon footprint in much the same way as you are expecting the large companies to do, as you are expecting the government to do. So the people, the profit, and the planet is all because of the people. It is not coming from anywhere else, So you have now reached a situation where you want vehicles and driven by batteries, which are only previously using to power headlights. You want to drive the whole vehicle. You want to drive it at very high speed, produce fit high performance tires, and for that you will have to have various types of rare earth metals, which you have to go to the moon and Mars to get it, or maybe the asteroid belt. So, are we headed in the right direction? There I am coming to what the young Greta Thunberg is asking, but she's asking your government, but I'm asking you. Next slide, please. Here. So now I think to spread awareness of the book, what I have initiated is for in this Param's conference, free copy for 3 lucky winners, and a 20% discount on all the persons who are attending this webinar until 31st December 2021. In India, the packaging and postage will be borne by me. But if you are an overseas person and you want to still have access to a hardcover, then packing and postage has to be charged extra. At the same time, I'm offering a preferential pricing for individual members of various textile and Indian Rubber Institute Association, just to spread the knowledge, and you just have to tell that which association you are affiliated with and claim the 20% discount. I own the copyright to this book, and any trade inquiries, or if you want to order copies for the moment for the hardcover edition, you please write to me at kesa1947@gmail.com, and I will answer every query as possible to the best of my abilities. Next slide, please. I think that's the last. Yes. Now, Param, I think we are coming to the photograph session. Now, this
Yes,
actually,
please share, your some of the memories, old memories. Yep, please go ahead.
so this is actually the campus magazine I have preserved for the simple reason, that it has got my photograph along with the director, deputy director of IIT Madras, Professor H.V.R. Iyengar, Dr. A. Ramchandran was the director, Professor Sampath was the deputy director, Dr. Nicholas Klein and Mr. Sethuraman were president of the Gymkhana and registrar respectively. And that's me on the dais. Yeah. Only one after shadow I will mention. After I joined Dunlop, the union leader of the Communist Union came to me and said, "Sir, we've heard that you are a student leader. Will you join our movement?" I think the comrades have a healthy respect for somebody who is able to swing elections and get there. But since the fellow in question had just waved a red flag at me in the morning saying that management trainees go back home and all that, I was not inclined to support his proposal. But throughout my stay in West Bengal, we had rather cordial relations with these people from various communist background, as well as 4 and 4-5, and there were large body of course contractors also, and so on and so forth, because man to man, they are all facing the same problem. We are in the same boat. Next photograph, please. This is again another VIP photograph. You see the governor of Tamil Nadu, Mr. Prabhudas Patwari of Congress in the returned Indira Gandhi era, 1979-80, I think. And to his left is Mr. K.J. Janakar, presently the chairman of Chennai IRI. And to his left is Mr. C.S. Krishnaswamy, who is a latex technologist, retired from Malaysia, and he was advisor to Trameco Rubber and Tea, Trivandrum, at that time. And here I am looking at the various scrolls or awards in front of me. The speaker is Mr. K.C. Sekar of Malaysia, also retired, and he used to give a lot of lectures in the Madras branch. And to his left is seated is Mr. George John, the legendary figure of MRF. Now, I brought it up because I was the only fellow in the picture other than the governor who was not getting an award that day. And when my mother saw the picture, she asked, "When are they going to give you one?" I said, "I'm still young by the standards of the industry. My day will come." It did come several years later, but it came by post, not through the hands of the governor as it used to be, handing a overseas degree or diploma. Next photo, please. This is my first visit to Japan, and that's me at the left. Next is Mr. Chibu of Taijin Limited Tokyo office, and after that is Mr. Ram Subramaniam from the finance division of Dunlop, and the young chap here is Yamamoto. Yamamoto figures in this story because as a young chap who had just joined a week earlier, he was told in our presence by Mr. Chibu, the one day Yamamoto, you will sit in this chair. And as Srinivasan said, the trainee was given the job of taking the two overseas visitors to a Taijin factory at Mihara, which is somewhere halfway between Osaka and Tokyo. And we are to catch the Shinkansen, that is a bullet train starting at Tokyo in those days. So Yamamoto took us to the station and we boarded the 9:23. When the train took off like a bird and Yamamoto came and suddenly got up from his seat, went to the next person in the next seat and asked some question, came back and said, threw his hands up and said, Shimata. So I was horrified that the fellow is going to draw out his sword and cut himself in the throat or something like that. Some crime has happened. Then he said words which were quite music to our ears, that we are on the wrong train. It so happened that we had boarded the 9:23 instead of the 9:26, and the 9:23 was a fast Tokyo to Osaka train. And so we landed in Osaka instead of Mihara. And to get to Mihara, we had to come back to Tokyo and then again take the right train, which took a greater part of half a day or more. And meanwhile, the news had spread to all the villagers in Mihara, and Yamamoto was greeted everywhere he went, and that this is a new boy who has joined and who took the visitors on the wrong train, So, Mr. Yamamoto, if you are registered for this program or somewhere, I would like to know where you are now and which chair you are sitting on. Next photograph, please. This is again a VIP thing. Mr. Biswas of the DGTD, he was the exhibition manager. I mean, he was the exhibition. He was opening the exhibition at that time, and exhibition was a forerunner of the many exhibitions to follow, and now it is a big event. At that time, we're very happy to put in a lot of work to get 33 exhibitors, 20% of them from abroad, and 5,000 footfalls in the exhibition. And I was grandly interviewed by Rubber Asia, where they said this was a signal success and we are going to go international and so on. And but I would just read the last paragraph. It says, Logi was candid about the shortcoming too. The one promise we could not fulfill was that of continuous educational video shows. We had the equipment, but not the video cassettes. Due to international copyright restrictions, many rubber educational video cassettes were not available for overseas screening, he added. Here, Param, I think you have set right that lacuna. Your videos are available now, and I think it's going all over the world. So that is one item at least I can cross off my list. Next slide, please. This is in Vietnam, where a similar situation of overloading prevailed as in the coal belt in India, of overloading tires. To make matters worse, they would pair tires of unequal diameter also, 920 and 1020 on the same part of the axle, and create some failures. It took a lot of education to try and convince them that this mixture or difference in outside diameter will cause havoc. Next step, please. Here is again in Sumitomo, you can see the Japanese gentleman is Mr. Kono, who was technical window man in Sumitomo Rubber Industries, and our group was led by Mr. Varghese Abraham. You can sit next to me. He was tucking away at Kobe beef and having a broad smile at that time. Later, he went and joined JK, and I think now he is a consultant and operating as a tire specialist. Next slide, please. This is in Taiwan, again, where a similar overloading situation prevailed as in Vietnam and India. Next slide, please. We're trying to explain how tires should not be overused. And here, this was taken in the Shahganj Compound Club, where I was moving into Shahganj, and Subramaniam, who was the vice president manufacturing at that time, was getting transferred to Ambattur. he was not replacing me, or I was not replacing him anyway. But we were part of a eight-member shuffle. A goes to B, B goes to C, C goes to D, some Z comes to A. The type of thing which companies do when they are in a panic and they are reshuffling all the cards in one hand, trying to add value. Next slide, please. This is a favorite picture of which I took from my rather poor camera on Mr. Peter Day, who had had 3 sessions in India as a technical director. We are at Mahabalipuram, and I was with one of his UK tire designers. He had just commented to me with a snort that what are these structures in the right and that in the left, that are monolithic structures and made of single stone and carved into beauty, and here you have put some mortar thing with concrete and slab and so on and so forth, which is hideous. So I defended it by saying this is modernization. What is monolithic has become a composite, and the Archaeological Society has erected a composite alongside the old one to coexist with the old. Next slide, please. This is again a grainy picture of retirees from Dunlop. They never imagined that the company would crash before they themselves did. Unfortunately, the gentleman in the center, E.T. Kochakrishnan, just passed away on Diwali Day this year. But this group, which is fairly strong, has had more than 50 meetings in Ambattur, and once a year, and only the last year we had to skip because of COVID and so on. Next slide, please. Here I am with at an exhibition with a machinery partner who was selling machinery presses and so on and so forth, part of my consultancy. Next, please. This is again taken when we had a good relations with Pakistan between just after General Musharraf had visited and made an agreement or non-agreement in Agra. The person at the left is Mr. Sethuraman, who was a partner in our consultancy. And the person extreme right is Jayakaran also, who was part of our company. And beside me is Mr. Maqbool Ahmed, who is one of the fathers of the Pakistan rubber industry. He was running a spinning cots and aprons factory in Karachi. He visited us and we visited them, and we made felt good progress in bilateral relations. Next, please. I think that's the last.
Yeah, that's all the. Well, thank you very much, sir. It's a lot of information, a lot of takeaways to all of us, a lot to learn on this. It's very useful. Your presentation and the way you covered everything what we need to learn. Thank you very much. Okay, let's we're in a little bit over the time, but I really like this whole information what you presented today to the audience, and I think young people definitely would be finding it very useful. The next is that in this program is that we invite some of your colleagues to share their association with you in their career. May I invite Mr. Ramani Subramaniam. He is also a well-experienced rubber technologist. He work associated with Mr. K.S. Loganathan, sir. Mr. Ramani, please come forward. You can share your, yep, go ahead.
Yeah, thank you, Param, for giving me this opportunity to talk about Mr. Loganathan. I would call him an encyclopedia. So this nothing I can talk in 5 minutes, but I have learned a lot. But I can say that I will structure it in 2 parts. One, I was working in SRF Limited, and then I came into contact with Mr. Loganathan in 1993 as a part of quality assurance and technical service. So I almost used to visit Dunlop, Ambattur at least once in a month. After the visits to the lab and all that. If Mr. Loganathan is available and free, I would squeeze in some 5 minutes, just say and convey my respects to him. Essentially, we were actually in awe, head of the whole technical of Dunlop, and man with tremendous knowledge. And that is one aspect is as a customer. Another aspect, I have interacted with him very closely when he was a consultant to SRF. That's when we worked together on a lot of projects. And then also we did a lot of projects together. It's not only in rubber, but basically I am a chemical engineer with synthetic fiber background. Mr. Loganathan is also a chemical engineer with a lot of tire and rubber background. But one key aspect I have always found with Mr. Loganathan is he can break it down to simple components and go back to your basic chemistry and physics. He had that kind of a knowledge. He can start from equation, Arrhenius theory, and activation energy and Brownian movement, and teach you everything from viscoelastic behavior to everything. So I really know Mr. Loganathan since 1993, but very closely from I think around 2004 or something. And then we did quite a lot of projects together when he was a consultant to SRF. One of the first projects we started was to have a lab scale dipping. Dunlop was the only company those days had a lab scale dipping, which is the simulating dipping process in a lab scale for a tire cord. So we had our differences on design, but finally agreed with me, and we said we will do a miniaturization of the big machine. And we indeed succeeded in doing that. And that is one of the masterpieces I have done with Mr. Loganathan. And we have developed some more machinery. The other two machineries we have developed was actually to do flex fatigue. There is no real machines or test equipment which is shared, no, not really available to gauge the life of the tire cord in service. So we try to simulate based on the number of flexing cycles it will undergo if it has to go 40,000 kilometers, and also simulated the compression tension and also the various angles and stresses. Then we developed actually a compression tension CT cord tester, and we were able to simulate and sort of predict what could be the life of a tire cord, which was, and we fabricated in with the local this one, which was another milestone I would say we had done with them. Then we had done a lot of joint projects. As such, the cycle tire cord was originally with cotton, then later with nylon. We were thinking, why not use a simple polyester yarn and then try making a cycle tire cord. So I took the help of Mr. Loganathan, and for a car tire, the polyester used is actually what is called an HMLS yarn, high modulus low shrinkage yarn. But we wanted to try with a high density yarn. But shrinkage was a factor there. So we actually made a special yarn in our plant and then developed the dipping process where the shrinkage has to be low. With the high density yarn, you can't get a shrinkage. But then we finally resorted to, instead of a 6 woven dipping, we did a 3 woven dipping and matched the requirements of one of the customers, Ralston Tires. And we were very successful in developing a polyester cycle tire cord, which is actually a pioneering work in India. Another thing I really did with him was I really learned the twisting process and the fatigue life of tires using nylon tires. So he actually taught me from basics, starting with helix angle, how to change the twist and why the twists are changed, what is the impact on the helix angle on the fatigue life. So when we were confronted with making a hybrid cord, see normally you twist the nylon yarn, which Mr. Loganathan also explained for making tires. Usually both the plies or either nylon or polyester, then we thought we should combine the properties of polyester and nylon, make a hybrid. So then we were stuck with what should be the twisting angle, because the polyester twists and nylon twists are different. Then we came with some ply twist and then the cable twist. We did many twisting trials and also dipping trials and came out with the right combination of twist as well as the dipping process. And then we developed actually a hybrid cord. Later we found that Goodyear was trying to use that in the radial tires. So this is a kind of cost reduction and also improve the fatigue life of radial tire. Also we have worked in conveyor belts. So once we are confronting to have a EPDM top. So we were working on what dip recipes one should use so that it becomes compatible with the EPDM. Otherwise, usually it is the synthetic fiber or NR-SBR blends. The other thing really had is we had series of sessions with Mr. Loganathan on tire technology, whether it is rubber physics, rubber chemistry, tire design, safety, then so many types of tires. And then I really learned about the aircraft tires from Mr. Loganathan. Those days, only Dunlop was making aircraft tires. No other company in India was making aircraft tires. I could understand and learn from him about the stringent requirements of an aircraft tires. And then he also helped us in evaluating different nylon yarns. Now, I also learned another one which is called the fracture analysis. When the tire fails, there is a rupture, there is a fracture, breakage of cord. How do you analyze and attribute and understand what is the kind of break to, and then how do you overcome that? So if you ask me, I can go on listing, and I used to pick up Mr. Loganathan from his house as he happened to stay very close to my house those days. So our 1 hour ride to Manali or 1.5 hours ride, we not only discuss technical things, we used to discuss even Tamil Nadu politics, Madam Jayalalitha, every aspect you can think of, or whatever test match or cricket match which goes on. So if you ask me, Mr. Loganathan is a treasure house of knowledge, not only in technical, but also worldly knowledge, and very calm and composed person. And is somebody whom I used to look up to, and then seek ideas, and he would take all efforts to explain very clearly. And I still remember they used to call him Logi in Dunlop. He was affectionately called Logi. I don't know, maybe very few people. So I used to know one Mr. D. Srinivasan very closely in the laboratory. I used to meet him and Kishore and then go to Mr. Loganathan. Then I used to tell him, sir, I want to meet Mr. Loganathan. You mean Logi? I said, yes, yes. So he was very popular but very knowledgeable, very respected person in the industry. I think it's very difficult to get a person with his technical skills, background, and experience and composure. And above all, he can call a spade a spade. I mean, he would not like to, satisfy you, please you. He is that kind of a person. But one thing I really found strange with him was I never used to see him using a computer and taking a printout. He used to literally write all reports with his own hand. I still have, I think, 1 or 2 reports he has given me. I have a copy, which is amazing. I mean, you can, gauge the patience of a person. If he is in the current age, he is able to sit and write para by one, and with a very legible, good handwriting. That is amazing, sir. Param, I can continue to talk a lot about Mr. Loganathan. I think I wish him all the very best, and with many more years of life so that he can serve our Indian rubber industry and contribute to the development of India further. Thank you.
Thank you, sir. Thank you very much, Mr. Ramani. So any words from Mr. Logi, sir? Logi, we call him Logi now onwards.
Yes, yes.
Oh, no, sorry, I have disclosed your name.
quite touched by what Ramani has to say, and practically every development of interest in the tire cord industry from 1973, I have been involved in some way or the other. And as Ramani said, from 93 onwards, we have been in touch and working closely on many projects. So it's good to hear from you and your own retirement and consultancy. I only advise, my advice to you is that please take care of your health, and you will be able to give more consultancy and help people for many more years to come. Thanks a lot, Ramani, for those nice words. Yeah.
Thank you, sir. Thank you.
Okay, thank you very much, Mr. Ramani. Okay, now our next guest is Mr. TV Ramachandran. He is not going to be on live, but he has sent us his video. Let me show screen his video.
Keep it on.
Fibers and rubbers indeed make strange bedfellows, one strong and directional, and the other weak and resilient, but also capable of vulcanization. A strong union between the two results in very durable rubber products that can be used in load-bearing applications, in passenger and goods transportation, in materials and mechanical power transmission. Between fiber manufacture and rubber industry applications, however, there exists a vast knowledge gap that can only be bridged by strong interdisciplinary technical education. Personally speaking, my 55-year career spans equally both tires and telecom, since I made a mid-career change to telecommunications. Many would consider the two to have little in common except the initial letter T, also in my name. However, tires and telecom have a great commonality in my opinion. Both are powerful enablers of mobility. Wheels and tires representing the original physical mobility of mankind, and telecom being an essential part of modern mobility and way of living. With 5G in fact coming our way now, advanced wireless service will soon be a very integral part of tire design and manufacturing. I have known Logi for over 5 decades as a great colleague in Dunlop and a good friend. I have followed his career very closely and his activities in research and consultancy with keen interest. His brilliant knowledge and understanding of the various complex aspects of rubber and tire manufacture are great, and he is also a very effective communicator. I'm very glad to learn, therefore, that Logi has written a book entitled Reinforcing Fibers in Tires and Mechanical Rubber Goods, which emphasizes the principles underlying textile and rubber technologies and the adhesives that bind them for life. It follows his earlier work, Rubber Engineering, which is very highly regarded as an aid to vocational training for technicians and technologists, and was published in association with the Indian Rubber Institute in 1998. I commend Logi's dedication to an interdisciplinary field for over 5 decades and his willingness to share his excellent knowledge so as to enable to teach youngsters by transforming their nascent ideas into a holistic and worthwhile education needed for the times. It's a tour de force performance from a master at the top of his game. Dear audience, I would recommend strongly that you do not skip anything in this or ask for more. What is not in his book is probably anyway useless.
Oh, very nice message. Thank you very much. It's sir, you have any words to Mr. TV Ramachandran?
He was actually a management trainee who joined 3 years before me in Dunlop, and my boss for quite some time at Ambattur and in head office. And he made a mid-career switch, and right now actually he could not come and give his own interview because he's chairing a session on 5G and privacy, for which he is the deputy chairman of the committee and so on. It's a 3-day conference, virtual conference going on, but he was kind enough to send this in advance and said you use it also in the book, which I've done.
Yes, well-spoken words from him. It's very nice. Thank you, Mr. TV Ramachandran, sir. It's great words. Thank you very much. Now invite the next colleague of yours, Mr. Sanatan Kundu. Mr. Sanatan Kundu, sir, can you please open your camera as well as the audio? Let me, yeah, okay. Okay. Yes, please. Go ahead.
Very good afternoon, sir.
Oh, good afternoon.
After a long time. Okay, I am very much delighted to get this opportunity to tell about my boss. Probably after 15 years, we will be talking, or I am getting this opportunity to talk to about my boss. Okay, he was Mr. K.S. Loganathan was my boss in Sahaganj, and really I was very much influenced on his knowledge, all square knowledge rather, overall knowledge, starting from tire engineering, compounding, textile. In fact, I also thought that time that I will also become like that, because he is almost 10 years senior to me that time. And whatever Mr. Ramani told, he is basically an encyclopedia, a treasure of knowledge in rubber industry. I will not tell tire only. Tire is main focus, but in general, definitely in any questions, anything, what was our clarification, we used to discuss and he used to answer. Second time, we met him when I was in Falcon. I was, before Dunlop closure, I have been shifted to Falcon in 1998 and working there as a assistant general manager technical, and he also came there as a technical head to guide us. So there also we had a lot of interaction, and very positive way we got his help, and he guided us as a very good team member, always try to influence the people. And what Mr. Ramani told, I also again repeating that, spade is spade. That was our main motto as a technical man. So we never used to compromise. A lot of people were there that time in Dunlop management. or any time, any management, there is a pressure. But technologists should have a ethics. They should not go beyond a limit. That is the learning, and that I also last 42 years I also practice that, because we have to look after the general public as well as the company both. We have a moral responsibility also. So in that way, he since my joining, that was a young blood in Dunlop Sagan. So his nature definitely influenced me that time, and really he was very much soft spoken. He never get angry with anybody, but quite logic, always convincing attitude to all the problem, like what he told, that the leader of CPIM came to him. After that, there is no problem. So naturally, all these logical people, there should not be any problem in life. I hope at 75 years, he is definitely going strong. Many more years to come. I wish him all the best in his future life, good health, and all the good things should happen. Thank you.
Thank you, Mr. Kundu, sir. Thank you very much. Very nice words. Any word from Mr. Logi, sir?
Yes,
Yeah.
I'm very happy to see Sanathan Kundu talk nicely about me. I think he joined Shaganj in the 80s, and as a fresh young graduate from the Hooghly itself, and was always quite enthusiastic about learning things, and so it was no surprise that he moved along in his career and to Falcon, where obviously he has thrived, because he probably the Kaveri waters and the climate has suited him better than the Hooghly or Ganges waters. But I'm very glad to see that you are now quite cheery as ever, and quite well settled, I should say. Thank you
Still,
very
I
much.
am in ITR. I am working as a chief operating officer in ITR. The Dunlop brand image we are carrying out now also. So
Yes, yes.
after Braja, I left and joined here in 2020.
Very good, very good. Keep the flag flying.
Trying. Okay, without compromising, because Dunlop quality, Dunlop like as this conveyor belt, belt, in the market, these are all available. Okay, all these factoring product.
Yeah.
Okay. Thank you very much, Kundu, sir. Thank you very much. Santana Kundu is also contributing various know-how webinars on the retrading compounding aspects as well. He's also contributing to the industry as a trainer, for the benefit of the industry. Thank you very much, Kundu, sir. Okay, now invite our next, guest of is Mr. PJ Swami. He's also rubber technologist with 40 years experience. He's also an entrepreneur. He owns a company, Forest Elastomech, India. He associated with the Mr. Loganathan for 4 decades. Please, Mr. Swami, please come on board and share your association about with Mr. Logi.
Thank you, Peram, for your kind introduction. Firstly, it is my pleasure and privilege to have an opportunity to say a few words about Mr. Loganathan. And I believe I am the last person to speak about him in this session. There are advantages and disadvantages of being the last speaker. One advantage is I can say that whatever I wanted to tell about Mr. Loganathan is already covered. So thank everybody and quit. Then audience also will be happy that session is getting closed. The disadvantage is I have to find something new than what has been already covered by people to speak about him. Fortunately, I have a lot to speak about Mr. Loganathan, but then it will require another session. So I'll try to restrict to my 5 minutes given. Now, my association with Mr. Loganathan has started in 1978 when I joined Dunlop after completing my post-graduation in electronics. I did my physics in electronics and I went to Dunlop. And in the interview, they asked me what I know about rubber, and I said I don't know anything. Then they said you are selected. I was surprised. Why? What is the reason? They wanted a mind fresh, without any preconceived notions. Then initially I was in the physical laboratory, and that time Mr. Loganathan was in charge of polymers and textiles. But I had a lot of opportunities to see him, his work, his approach to life, etc. Now, what I am going to speak now, what are the characteristics that made him unique? One is his excellent knowledge of the subject matter, but there are some personal traits of him which made him what he is today. Firstly, I will say about his attachment to the organization. See, normally we professionals, very rarely we are attached to the companies where we work. We skip the, I mean, we change the jobs very frequently. We talk ill about the organization when we come out of that. But Mr. Loganathan, I think he decided he will retire only in Dunlop. He was fully committed to the organization. You see, in Dunlop, there is one concept called management trainees. I think Mr. Loganathan also was a management trainee. And, it is a British hierarchy. They are upper level of the society, so very, very difficult to get access to them as and when we want and meet them and all that. But I had a good access to his secretary, so I know what is happening in his, they say, if you want to know more about a boss, first find out what through his secretary. Okay. Now I believe Mr. Loganathan used to get offer letters, very attractive letters from different companies offering maybe double, triple the salary of Dunlop. I'm not exaggerating. I was told he will give to his secretary to tear off and put it in the dustbin. He even doesn't read what letter, what they are giving. He was so dedicated to the company. He was very proud of being a Dunlopian. And I also developed that, that attachment to the organization. But I had to leave in between when I guessed that Dunlop is going to sink after some time. Now, one more thing I found from him is integrity. You see, as a extremely respected specialist in textiles in Dunlop those days, I was told that not only in Dunlop, Ambattur and Shahganj, even overseas worldwide, he was the last word related to any textile specification, design, testing. Ultimate, he is the ultimate. So he had access to so much of knowledge. It was very easy for him to leak it and make money out of that, which even those days people were making. See, for example, if you see the major frauds in corporates, they are not made by illiterate people or small people. They are highly intelligent people who do that. They are MBAs from Harvard and all that. So then it is very difficult when you have that to make yourself an ethical person. So he was very ethical. Nothing, not even one word will go out of that. So this I learned from him, and I will tell you by two examples how I inculcated that. In those days I went there, that factory was in a sheet. I came and told these are not right people to mix the compound for us. So one day he came to Dunlop, met me at the entrance, and he said, Mr. Swami, I believe you are looking for a job for your brother. I said, yes, I am looking for a job for my brother. He said, you can come tomorrow. Thank you very much. No. For that, you have to give me the tire formulations of Dunlop. I told him, no, I can't give you that. Then he said, if you don't give me, I can take from elsewhere. I said, you please do. But from my side, you don't get even what rubber grade we are buying. I'm sorry for that. Then my brother did not get the job in his company. That is the loss I had for following Mr. Loganathan's ethics. Okay, this is one side of that. I left Dunlop, joined a non-tire company in Bombay, and in the interview, they asked me, Mr. Swami, you are from Dunlop. Can you bring all their formulations? I told them, no. Whatever I have got in my mind, I'll bring, but I will not be able to bring anything. And surprisingly, they selected me for the job. Now, after 5-6 years, when the MD was talking to me, he said, Mr. Swami, one of the reasons why we selected you. I said, please tell me. When we asked you whether you can bring all Dunlop formulations, you said no. Just before we interviewed one guy from Spenner. When we asked him, can you bring all the formula, he said, I will bring entire process manual with me. So then we thought, this guy, if we can do that to Fenner, he will do us tomorrow also. So this ethics, what I learned from him, has helped me a lot. And I only changed my career one time. Then I was there in that company for 20 years, made the company very strong, and then I became a consultant. So these two ethics, what I cultivated from him, one is you have to be very proud of the company you are working, and you have to maintain your ethics, which are very, very difficult those days and even now. Now, another thing what I learned from him is he is not a shallow person. Anything he does, he goes meticulously deep into that. I find nowadays, even those days, many professionals are swimmers. They can do anything on the surface, but ask them to just go 1 foot below and find out what is there, they get suffocated, and some people, they come back immediately. So he has got the patience of everything, analyzing in a proper manner. And those days, as Mr. Ramani was telling, there were no computers and all. That's why I think he got everything. He will write by his beautiful handwriting, which is same now. Even after so many years, there is no change in his the stroke or the angle or letter, whatever is there. No, he was so meticulous about that. So it is nice that he then about the knowledge. Of course, he is as people said, he's the encyclopedia of rubber technology. Initially, he started with textiles, then got into rubber. Now, when he wrote the book Rubber Engineering, it is a reference book to all rubber companies. You will find them on the MD's table. Anytime you have a problem, you can always go and refer to that. So these are the characteristics which is continuing even today. And about Mr. Ramani was mentioning that aircraft tires that time Dunlop was making, that brought me to my mind one anecdote. Sir, you remember that those days there was an advertisement from Madura Courts, and you wrote a letter to them. Can you tell the audience what happened in that? They will be interested to know that.
Yes, actually, it happened in the late 70s when Madura Coats was trying to change the image from being a cotton converting company to a synthetic fiber manufacturer and converter. It got a license for making nylon tire cord also, which in those days was a license to print money. So a public relations campaign was launched by the then managing director of Madura Coats, Mr. S.K. Malhotra, who engaged a publicity firm to bring out that Madura Coats is making products which are high tech and used in aircraft tires and so on and so forth and all that. Unfortunately, the ad agency which was interested in the job neither talked to anybody in Madura Coats nor with Dunlop, and produced some ad copy which gave the picture of an aircraft tire taken from a truck tire manual. So I wrote this to Mr. Malhotra saying that this is not correct. Please change the image. Mr. Malhotra fired the agency and refused payment for whatever ads were there, and he pulled it out and of that campaign. But this is explains the relationship between Dunlop and Madura Coats. When you have the biannual meetings and when the people, you don't want to see them fall or make a mistake which make them a laughing stock in public. So I thought it was my duty to tell them, and he thought it was his duty to comply with whatever came his way. So that is the incident is Janal Swami is talking about. I almost forgot about it until we brought it up now.
That shows how importance is given to small details. The pattern of the tire got his attention in a newspaper where you normally look for a minute and get out. And one more thing which I found very interesting about Mr. Loganathan, which I think very few people I can think of. There is one industry called follow-up industry. This is what the Clintas MD was telling. The world is full of follow-up industry people, where it is running into billions of dollars. That is, I follow up with you and you follow up with me, nothing happens in between, no? And Mr. Loganathan, I don't remember one time where somebody had to remind him and say, this is what your company. Those days there were no smartphones and automatic reminders and all that. Everything had to be written in your diary. I don't recollect any time he missing his timing of a meeting or a commitment. But he could do because of his personal trait. But another thing he had, which was very difficult, he never followed with anybody. See, you need not allow people to follow you, but you don't follow. I will give you one example. I don't know, Loganathan, you remember or not. You used to travel very frequently to Shagaj. One day I was sitting with you and you were to leave at 3:30 flight or something. Till that time your ticket did not come and I did not see any tension in you. I asked you, sir, you have to, he said, if I have to go, the ticket will come. If it is not coming, I am not going to go there. Why I should follow? Where is my ticket? Where is my ticket? Where is my ticket? That shows, it is a system that should work. Now I find in many companies, when company wants us to go, we want to ask, is my ticket booked, is my hotel booked, because you are keen to go, but company also should think that this person is going and we have to take care of, so he never used to follow with people and he won't follow. That's very difficult thing which I following in my life. In my company also, if I see anybody more than 5 minutes waiting outside, I ask whom you want to wait and what is happening, then the person has to come and explain why that person has been waiting here. So nice. I like this. I can talk a lot of things, but sir, only one question I have got on behalf of the audience. In your rubber engineering book, you wrote K.S. Loganathan. Now in the new book, you put Keshava Shiva Loganathan. Now, is it a crossover? You want to say whether it is Keshava or Shiva? Both. It is. Nobody can be only Keshava. Nobody cannot be Shiva. You have to be both Shiva and Vishnu. It is not one thing. What is the reason for making your name longer than what it was already there?
No, same man, different hat.
Oh, okay. I thought it is a crossover from Keshava, KH to Keshava Shiva Loganathan. So thank you, sir. It's my pleasure to talk to you. And later, sorry to say that we had a good association when I became a consultant also. We have a engineering rubber research institute where we together did assignments to few companies, and it was a very good experience to have your one-time boss as your then as a role model, then as your colleague. But he quickly changed. When I was moving with him as a colleague, never imagined he was my boss in Dunlop, where I used to 10 times before think 10 times before knocking his door and getting into that. That's very nice of you that you have moved so fast from one phase to the other phase. And I wish you all the best for the in future, and you should continue to guide and support rubber industry to the best as you are already doing. Thank you.
Okay, thank you very much, Mr. Swami. Any final words to Mr. Swami?
No, we are in close touch, and he has already asked me to take some of his time, and I think we should move on.
Yeah. Okay, thank you very much. Thank you, Mr. Swami. May I request Dr. Samar to come forward and share a few thank you words to all the panelists, please. May I request all other panelists as well to open their webcams, please. Mr. Kundu? Yep, okay.
Yeah. First of all, thanks to Ramani sir for agreeing to be present for this function. I sincerely thank you, sir, for making this function a successful one. And Loganathan sir, you are one of the best person that I have come to know out of these four gentlemen. And I really feel proud that we are doing or hosting this program for you. Thanks to Kunduda. Really, you told some very nice things, and our sincere thanks to you. And PJ Swami sir, Janardhan Swamiji.
Yeah, no
Only
name. Yeah.
2-3 days back, I came to know about him, and the way you are saying the things about Loganathan sir, we came to know many things. And salute to you, sir, for bringing all these out. Thanks to everybody. And thanks, Peram, for hosting this program. Thank you very much.
Okay, thank you very much. I really enjoyed this. You know, it is longer, but I really enjoyed. I did not want to disturb even 1 second to the flow of the information. Everything is a learning. Everything is a learning.
Yeah.
Thank you very much. Okay, now we get into the next part of the program, that is a lucky draw. I'm sure if still people are there, and I'm sure they'd like to get a copy of uh, his book. You know, it's a 500 pages book, reinforcing fibers in tires and mechanical rubber goods. We have done a lucky draw, and I have asked my daughter to help me to pick up the winners. Okay, so let me show you. I'm not biased to anyone. So whoever registered, and if they are still here, they have a chance to win this book, and Mr. Loganathan will send to them directly with signature as well. Let me show you the video. Hello everyone. As you know, as part of this Eminent Personality webinar, we have a lucky draw. The lucky draw has basically the prize is the book written by the Mr. K.S. Loganathan. Today I have with me is my daughter Durga. She is 9 years old. I asked her to be part of this lucky draw, and she'll be taking first three winners. Basically, this program we have three winners. First, you will take the three winners, and then after the I also take additional three winners in case the first three winners are not there during the announcement of the program. Okay, Durga, are you ready?
Very.
Thank you very much. Okay, let's do that. First win. Take the first winner. You want to juggle it? Yeah. Okay.
The first winner is.
You can show to the screen of camera.
76.
76. The winner number 76 is Mr. Yogesh Sharma from Forex. He's an assistant manager. Okay, he is the first winner. Number 7, first winner. Okay, the next one, Durga.
The next one is 101.
101. We have 101. Okay, 101 is Dr. Lenny Matthew, is a professor at the Mangalam College of Engineering. Congratulations, Dr. Lenny Matthew. Okay, number 2. Okay, yes, number 3. Please proceed.
Number 3 is 39.
39. Okay, correct number is 39. Okay, the name Nirmal Selvan from Roop Polymer. He is a senior general manager. Okay, congratulations, Mr. Selvan. Okay, let's take additional 3 more. In case these first three people is not going to be there, we will give it to the other people. Okay, yeah, let's take the number 4, please.
Our number 4
Show properly.
is 51.
51. Number 4 is a 51. Okay, Mr. K.V. Gopalakrishnan from LG Ultra. Okay, number 4 is yes. Okay. Okay, can you take it number 5, please?
Number 5 is 97.
97. 97 is Mohammad Ibrahim. He is from Polyhost India Limited. He is an assistant manager. Okay, number 5. Okay, number 6, the last one, please.
And last but not least is 103.
103. Number 103 is Shiv. Just a second. 103 is Debanjan Paul. He is from the University of Calcutta. He's a student now. Congratulations, Paul. Okay, number 6. Okay, thank you very much, Durga. Suppose first 3 winners they are there. Do you think other people get disappointed? So we can ask Mr. K.S. Loganathan to give more discount for these people if they want to buy the book. Is it a good idea?
Yes, and I bet those lucky 3 winners and other people who bought his book will love it.
Super, yeah, definitely. It's a very big book. It's a 500 pages, huge information. Okay, that's all. Thank you very much, Durga, for joining me to do this lucky draw today. Okay, do you want to say final words to the winners and also Mr. K.S. Loganathan?
I would like to say congratulations to the lucky 3 winners, and I hope you like his book.
Okay, yeah, that's it's a 5 minute long, and actually, I mean, I want to be truthful on the lucky draw, so I took my daughter to the part of this program.
Hi, Param.
Yeah.
Hi, Param.
Yes.
Hello.
Hi.
I want to
Can you
interrupt
hear
you
me?
just for a minute, not more than that.
Sure. Sure.
Can I?
Yeah. Go ahead. Yeah.
Yeah, one of the other very unique characteristics of, because with this I'll stop, I will not extend. Unique characteristic of Mr. Loganathan is you cannot find any imperfection or mistake in whatever he does. If it means overnight he will give the required time, but you cannot find any mistake in his work. Okay. Now I'm giving an offer. If any of the readers of the book which he has written now, if they find even one mistake, just one mistake, I will refund the entire cost of the book to them at my cost.
Wow.
They have to either write to you or my number 9673001538. Just send an SMS. Tell what mistake you found on what page, and you will get either a new book free of cost or refund of what you purchased.
Okay, guys, that's a challenge. Is I'm sure you want somebody, the good side of it, you read the book completely. Yeah, whether you find or not, but it's a good challenge, Mr. Swami. Appreciate that. Okay, actually the first 3 winners were not here. Okay, we have only the 2 people are here. Mr. KB Gopalakrishnan, actually, he's also, I move him as a panelist. If he can open his audio, he can speak now. Mr. Gopalakrishnan, you can open your audio. Yes, you are the winner. Yes. You like to say a few words to you, or Mr. Logi also can say a few words, please. Yeah.
Thank you, but actually speaking, Logi was my boss. After completing my college, the first job was in Dunlap under Logi. He he only guided me in the technical textiles, and this book he has sent me as a compliment for the. I was the first person to get the compliment. So I think you have to give it to one any other person. One more draw you have to take and give it to another person.
Okay, we can do that. We can do that. I think there is one more. Debanjan Paul is there. I think you can open your webcam. I think, yeah, your webcam is there. Yeah, can you open it?
No, I don't have webcam.
Okay, yeah, fine. Yeah, go ahead. Yeah, you're from Calcutta University. You are which year student?
I am now in 3rd year, BTech student.
Okay, and doing the polymer technology program?
Yes, polymer science and technology.
Sir, Logi sir,
thank you.
Logi sir, any words to the young student? You please take a challenge of Mr. Swami. Find a mistakes from his book. Okay. So, Mr. Logi sir, any words to the young guy? Yeah.
It's good that somebody who is still pursuing his studies is attending an industry webinar, and getting interested in subjects which may be not taught anywhere. So I wish him well, and to go through this book diligently and see if he should pursue a career in technical or industrial textiles or not. All the best for a successful career.
Thank you, sir.
Okay, good luck to you, Devanjan. The book will be sent to you. I will pass your address to Logi sir, and it will be taken care of. Yeah. Okay, and the other books I do suggest maybe pass to the libraries. I believe that Ms. Logi sir will be passing to the library. Maybe more students and young people will make use of it. Yeah.
Yes, certainly, certainly.
Yeah.
Yeah.
Yeah, that's all the questions we take. I think that's been a good, very, very good program, sir. I wish that we can take a longer time on this whole the program more. Maybe personally,
And
I really enjoy.
you will get to be 75 years,
Yes.
by the time the conversation is over. Yeah.
It's wow. I mean, if you look at the panelists' remarks and the one you mentioned your in a presentation, lot of takeaways for the people, whether you are in whether a young person or a senior person, values, knowledge, and even the things that you are mentioning about the young, what kind of things you look forward in the future, and carbon footprint. I mean, that statement is wow. You what are the books you read yourself, how many trees you cut, and how many you actually that's what I also want to preach everybody. Please plant more trees, please plant more trees. That's what, as a technobiz, I try to, in every program I try to give the message. And you, man, Logi, I mean, let me call you with love that Logi, you're really super, sir. Thank you very much. I'm really honored to have you on this as part of this Eminent Rubber Industry Professional Program. And I wanted to continue the journey with you for a long time, doing more together in whichever the possible way, whatever is convenient to you. Yeah, thank you very much. I want to take, give final remarks to the, audience, so that, kind of take, as before we end the program. Yeah, please, sir.
Well, it has been a very good journey for me also, going down memory lane and looking up things where the projects have been completed satisfactorily, not completed, or projects which are probably going to be taking place in the future. So I'm crave the audience and your pardon for taking more time than normally is taken for these things. But basically, I felt that it should be future orientated rather than talk about only my achievements and what I have done in the last 50 or 52 years. It is still, a lot of it is unfinished work, and I would suggest that that the youngsters take some note of it and read my book and try to do something more for society. Thank you very much, all of you, for your patience.
Okay, thank you very much, Logi sir. I also encourage, I do help, from our side also to reach out the book to the more audience, more, readers, okay, through our Technobiz platform as well. It's, actually, Mr. PJ Swami mentioned it's challenging. It shows that how much effort is there and what kind of contribution I've done. Not I saw the rubber engineering. Now it's another piece came out. Okay, so let's make industry take the benefit out of this new book, and Technobiz will support you in the every way possible. Yeah, thank you very much. And once again, it's honor to have you as a part of this program, and please stay healthy, and as everybody wished, continue to support industry as long as you can, and we like to be part of this your journey together as well. Thanks once again.
Thank you.
Guys, that's the end of this program. I know it's long than expected, but every minute is valuable in this, and so I'm hoping that you found it useful. If you not join this program today, it's all available in our YouTube channel also, or you can review through it whenever you want. A lot to learn. I want to invite all of you to join our future programs with an eminent rubber industry professional. You can see the list, the legacy of in the eminent rubber industry, Dr. Samir Majumdar. I think probably you know him. Many of you know. Okay, he's no more. So we review his journey. And we have from Sri Lanka, an entrepreneur and really philanthropy, and then also he's from the DSA Samsung Group, Mr. Kulothanga Rajapaksa. There are many others. Dr. Rabin Datta is another eminent person, and Mr. Sudhir Gautam, and Dr. Pranab Kumar, um, and Professor Golok Nando, and Mr. Sheel Chandra Jain. Lot is in the plan. Okay, so I wanted you guys join on a regular basis. Usually it is on the Saturdays, alternate Saturdays. So please be in touch and stay tuned on this program. A lot to learn from these eminent persons. Okay, and Mr. N. Rajagopalan, Mr. Arun Kapoor. And if you miss or if you wanted to view old programs, it is all available there in our channel, Technologist channel. Please watch and whenever it is convenient to you. Okay. As you know, Mr. Logi has mentioned about carbon footprint. This is my way of ending the program with please grow more trees in the surroundings of your home and your workplace, because these are the places you really spend the time. Okay, you don't need to blame the all over the world what's problem, but I think we can look after around ourselves, surroundings, home and workplace. Keep it green, plant more trees. That's really you can make a change. If everybody does it, I think it's a lot of change happens, a lot of good happen to all of us. Okay, with that, thank you all. End this program now here. Dr. Samar, thanks once again, and Mr. Logi sir, I'm going to close this webinar now. Thank you very much. Yeah, we'll be in touch. Thank you.